Good day, this is Professor Will, CBFD PhD, and today's Wednesday, December 15, 2021. It is 2:11:41 p.m. Eastern Standard Time. Today's research, Diagnostics MRI. So let's hop to it here. A new spin on MRI, date December 13, 2021. Source, University of Tsukuba. Researchers have demonstrated a proof of concept modification to enable standard MRI systems to detect frequencies associated with the presence of sodium-23 ions. And this low-cost and convenient approach requires the installation of a radio frequency repeater inside the magnetic bore of an MRI machine. The wide applicability of this method for sodium and other nuclei may allow advanced medical imaging to be performed on existing machines and substantially reduce MRI scanner upgrade costs for hospitals. Magnetic resonance imaging has become a crucial part of the medical toolkit for non-invasive visualization of internal organs. MRI machines operate by placing the patient in a very strong magnetic field, which will cause the nuclear spins of atoms in the body to align in the same direction, especially acting like tiny magnets. Then a radio frequency, RF, signal of a very specific frequency is applied, which has the ability to flip the direction of the spins. When the nuclei relax back to their original aligned state, the precision of these spins about the magnetic field direction can be measured by RF detector coils to determine the concentration of that particular atom. The majority of MRI machines in use today are optimized to look for the presence of hydrogen 1+ nuclei, which are naturally abundant in the body as a component of water molecules. Retrofitting such a machine for detecting other isotopes, like sodium-23, 23 sodium, would require a great deal of expensive hardware upgrades. Researchers demonstrated a proof of concept method for equipping a conventional MRI machine with the capability to image 23 sodium by installing a crossband RF repeater system. And this is a device that receives signals at a certain frequency and rebroadcasts at a different one. The RF repeater, which is a commonly used device in amateur radio, can be placed directly inside the magnetic bore of an existing MRI machine as a cost-effective upgrade. And this allows a frequency produced by 23 sodium, which is around 17 megahertz, to be detected by the coils tuned at 64 megahertz of MRI. The research team tested the system with a saline phantom and an anesthetized mouse, even though the resulting signal was much lower compared with custom-built 23 sodium machines that could be amplified to produce comparable images. Watching the motion of sodium ions inside the body provides detailed metabolic information not available from conventional MRI images. 23 sodium imaging has already been shown to be useful for applications involving the kidney, owing to its large sodium concentration, as well as the brain and heart. And this approach may substantially reduce healthcare costs by providing completely new abilities to existing machines without requiring a complete refurbishment. Good day, this is Professor Will, CBFD PhD, on microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.